For most of my life, humanoid robots that walk, use their hands, navigate the real world, existed in two places: movies and research labs. They were impressive demos that never left the controlled environment. They'd fall over, they'd freeze up, they couldn't do anything practical. Something changed in the last 2 years. Multiple companies have now deployed humanoid robots in actual work environments, not demos, real production deployments, and the capability improvements are coming at a pace that's genuinely hard to believe if you're not actively watching this space. This is one of the most important hardware technology developments happening right now, and most people aren't paying close enough attention. Before getting into the companies and the hardware, let me explain why the humanoid form factor specifically is getting so much attention and investment. The world is built for humans. Our homes, factories, warehouses, vehicles, tools, offices, designed for bodies with 2 arms, 2 legs, hands that grasp, heads that look around. The existing built environment and the entire tooling of human civilization doesn't need to be rebuilt if robots are humanoid. A robot with human-like dexterity can use a wrench designed for human hands. It can navigate a hallway sized for a person. It can use a ladder designed for bipedal creatures. Specialized robots have dominated industrial automation for decades. Robotic arms on factory floors, automated vehicles in warehouses, machinery designed for specific tasks. These are enormously valuable but require purpose-built environments and can't generalize. A robotic arm bolted to a factory floor can assemble one specific product line. A humanoid robot could, in principle, do any physical task that requires roughly human-shaped manipulation in roughly human-scale environments. This is the long-term thesis. A sufficiently capable humanoid robot is a general-purpose physical labor platform. You update its software to give it new skills rather than building new specialized hardware for every new task. Let's run through who's actually in this race, because the field has gotten crowded fast. Boston Dynamics has been building bipedal and quadrupedal robots for decades. Their Atlas robot has been doing backflips and parkour on YouTube for years. Impressive athletically, but not commercially deployed. In 2024, Boston Dynamics retired the hydraulic Atlas and unveiled a fully electric version, signaling a shift toward commercial deployment. Their Spot quadruped is already commercially deployed for inspection and industrial tasks. Figure AI launched in 2022 and has attracted enormous investor attention, raising over $675 million, including from Microsoft, NVIDIA, Jeff Bezos, and others. Their Figure 01 robot has been demonstrated doing tasks like making coffee and manipulating objects on a bench. BMW has signed an agreement with Figure to test humanoid robots in manufacturing. Physical Intelligence, PI, is an AI-first robotics startup founded by former OpenAI researchers focused on building the foundational AI models for robot learning. They raised $400 million in 2024 and are working on training models that allow robots to learn from video demonstrations and transfer skills across different embodiments. Agility Robotics, owned by Amazon, has their Digit robot actively working in Amazon warehouse facilities. This is arguably the most significant real-world deployment story, a humanoid robot doing actual commercial work at scale in a production environment. Digit moves totes, handles packages, and works alongside human workers. Tesla Optimus is probably the most watched robotics project given Elon Musk's ambitions for it. Tesla claims to have Optimus working in their Fremont factory doing battery cell sorting and other tasks. Musk has made extraordinary claims about eventually producing millions of Optimus robots. The track record on Musk timelines is mixed, but Tesla's manufacturing expert eyes and AI capabilities make them a serious player. 1X Technologies, formerly Helodai Robotics, and Apptronic round out the main players with active development programs. The robots of 10 years ago could execute pre-programmed routines fairly well. The robots of today can perceive, understand, and respond to the real world in a much more flexible way. What changed? AI. The AI revolution, particularly large multimodal models, has transformed what's possible in robot perception and decision-making. Vision Language Action, VLA, models. These are AI systems that combine the understanding of language, visual perception, and physical action planning into a single model. A robot equipped with a VLA model can receive instructions in natural language, Pick up the red cup and put it on the counter. See its environment, understand the instruction in context, and plan and execute the physical actions to accomplish it. This was not possible with pre-AI robotics approaches. Learning from demonstration and video, rather than programming robots step by step for every task, modern approaches allow robots to learn from demonstrations, watching humans perform tasks on video, or through kinesthetic teaching, where a human physically guides the robot through a motion. The AI learns the underlying skill and can generalize it. Sim-to-real transfer. Training robots entirely in physical reality is expensive and slow. Modern methods train robots extensively in physics simulation, generating billions of training examples computationally, then transfer those skills to physical hardware. NVIDIA's Isaac simulation platform has become a major tool for this. If you want to understand the fundamental difficulty of humanoid robotics, focus on the hands. Human hands are extraordinarily capable tools. 27 bones, 29 joints, over 30 muscles, capable of delicate manipulation, threading a needle, and powerful grip, opening a stuck jar lid, and everything in between. Our brains dedicate a disproportionate amount of neural processing to hand control. Robotic hands have been an active research area for decades, and while significant progress has been made, replicating the full dexterity of human hands remains deeply challenging. Current robotic hands are generally either parallel gripper style, 2 or 3 fingers, good for grasping but limited finesse, or more anthropomorphic, multiple fingers, better dexterity, but mechanically complex and failure-prone. The companies making fastest progress on dexterous manipulation are those combining improved hardware with AI that allows learning fine motor skills rather than programming them explicitly. Teaching a robot to fold laundry, which requires manipulating soft, deformable objects that change shape unpredictably, has been a benchmark task. For the first time, robots are beginning to do this reliably. Who actually buys these robots and why? The first big market is manufacturing and warehousing. The logistics industry is massive, labor-intensive, and increasingly struggling to find workers for difficult, repetitive, physically demanding jobs. Amazon warehouses, automotive factories, semiconductor fabs, these are natural early markets. The economics are compelling in theory. A robot that costs, say, $50,000 to $100,000 and can work 24 hours a day, doesn't get injured, doesn't call in sick, and can be updated with new skills via software, can compete economically with human labor for many tasks, even at current price points. As scale drives down manufacturing costs, the economics improve further. The second major market is elder care and healthcare. Aging populations in developed countries create enormous demand for physical caregiving that existing labor pools can't meet. Robots that can assist with patient mobility, medication delivery, basic care tasks, and facility maintenance could fill a genuine need. The third market is hazardous environments: construction, utilities, mining, immersion, psi response, work that's dangerous for humans. Robots that can work in extreme temperatures, confined spaces, or environments with toxic materials are valuable even at high cost. Where are we realistically in terms of commercial scale? Today, limited commercial deployments in controlled environments, warehouses, specific factory tasks. Robots that can handle a narrow set of defined tasks with acceptable reliability. 2025-2027, expanding deployments in manufacturing and logistics. Improved dexterity enabling more manipulation tasks. Cost reductions as volume increases. More general-purpose capability as AI models improve. 2028-2032, potentially reaching price points and capability levels where humanoid robots become widely commercially viable across multiple sectors. Beginning of genuine labor market impact in physical work. Beyond that, the long-range scenario that some researchers and investors believe in, highly capable general-purpose humanoid robots as a transformative economic force. Whether this materializes on the aggressive timelines sometimes cited is highly uncertain. What to watch? The reliability metrics. How long can robots work continuously without failure? What fraction of tasks can they complete successfully without human intervention? These numbers, not just demonstration videos, are what separate commercially viable robotics from impressive research projects. The humanoid robot revolution isn't quite here yet, but it's closer than it's ever been. and the pace of progress is accelerating. The convergence of better AI, better actuators, better sensors, and massive investment capital is producing something real. Whether the transformative moment is 5 years away or 15 is uncertain. That it's coming seems increasingly clear. I'll keep covering robotics as the technology evolves. It's one of the most consequential physical technology developments of this era. Subscribe for weekly coverage of the technology changes that are reshaping the world. Drop a comment. What application for humanoid robots do you find most interesting? See you next week.